Hey everybody, welcome back to example 2. We're going to talk about compound interest in this video. And we have a problem here. It says Julia invested $17,000 in an account paying an interest rate of 2.4%, compounded monthly, assuming no deposits or withdrawals are made. How long will it take to the nearest tenth? And there's that word, that phrase again, how long? That's telling us we're solving for t. To the nearest tenth of a year for the value of the account to reach 21,400. So this is a lot like the last problem, only it's got a compounding interval. Okay, so here's the formulas that go with these. This is the same formula we saw up there. This is a basic one. If it's just simple interest over t years, it's a basic compounding formula that you see at the top, because the compounding interval is 1. If it is compounding n times per year, which we were just told monthly, then n is not 1 anymore. So how many months are in a year? Well, n would be 12, right? And we have the same r, which is the rate, and time t. So that's the formula we need to use for this one. Okay, it did not say continuously. Had it said that, we would have used this one. So we're looking for the compounding interval when we read these problems, okay? And that indicates the formula I'm using. So this is not my formula. Sorry about that, guys. So we're going to use this formula right here. Oh, these videos are so much more fun without my tablet to write on. They do seem to get a little bit crazy. So here we go. This is our formula we're going to use. And I think we'll just start filling it in from here. How about that? All right, so let's go back in here and write this in an equation. So we know, let me space a couple there. We want A of t equal to, what's my principal? How much are we putting in? 17,000. And we're gonna need our 1. You know, I probably should have done this, open a set of parentheses, because it's going to have a fraction in there. 1 plus r over n. Our r is this right here. We need to move our decimal over. So we get 0.024. We talked about n. It's being compounded monthly, so that makes n 12. And it's going to be raised to the 12t. And that's what we need to work on. Now, we're told, I'm going to copy that. I'm going to get smarter as I go along here, guys. We're told that we want it to get to 21,400. So that's what goes right here, actually. A of t is going to be your 21,400. And there's the equation we actually need to solve. Right? Now, the first step, I'm going to have to say this in steps because we don't want to rewrite this over and over again because it's going to take up all of our video time. We want to divide by, again, isolate the exponential and do some simplifying as you go. So what I'm going to do now is I'm going to divide both sides of this thing by 17,000. And at the same time, I'm going to combine this inside 1 plus this fraction here to give me something a little more simple to write, okay? So that'll be my next move. And when I do that, since I've already worked this one out, I get, let's see, a fraction. I left it as a fraction. When you divide 21,400 by 17,000, you get 107 over 85. Okay? And that's going to be equal to the parentheses. When I combine this stuff inside, I got 1.002. And now that's raised to the 12t. Okay? All right, so let's talk about the next step. Next step, you're going to take the log of both sides. I'm using log base 10, and you're going to get something like this. Insert equation. You're going to get log of this equal, I'm supposed to already be in my equation mode, but you know what? That works. You can understand what that means. 1.002 raised to the 12t. Okay? All right, so let's talk about the next step. What's going to happen here? We're going to have this, but only we're going to use the third law of logarithms to move that 12t out front. And then basically we could say that, well, let's do that step first and we'll talk about what's next. Don't get too far ahead of myself here. And move this down, paste it back, and now we're going to take this 12t, and that guy can live out front, or I'll just remove it. Might be simpler just to write it again. Right? And that's what you'd have. So in other words, to isolate t now, it's going to be a matter of dividing by 12 log 1.002, and that would solve this equation for us. So the final answer here would be, the exact answer would be t equals this log You know, I'm having a lot of trouble with these fractions today. I'm just not having the best luck of all, am I? There it goes, finally. And I'm going to write this kind of goofy. I can't seem to get it to put the parenthesis in that equation for me. There it goes. And we're going to be dividing this by 12 log. Of 1.002. And that is going to be approximately, we'll show you how to do that if you needed to know. So we're going to have log of 107 divided by 85 divided by, be careful with this, I'm putting that in parentheses for a reason, 12 log 1.002 close, and I get 9.6. So we'd say approximately 9.6 years to the nearest tenth of a year. Okay, so we could say approximately 9.6. And we're going to go to find that symbol. All right, I wanted to do one more equation in this video. It's going to make this video long. I'll fix this for the notes. That's sloppy looking. It's saying this divided by that. All right, so we got Robert invested $7,600 in the account, paying an interest rate of 1.9% compounded continuously. Okay, so when it says continuously, you're using this formula. All right, so we're going to use this guy on this problem. And we talked about this a few videos back, what they mean by continuously and how the formula evolved and all of that. So we probably don't need to get into that all here. And let's plug in everything we know. We'll put us another equation right there. All right, so what is the principal? The amount being invested, $7,600. Oops, that did not work. All right, what's the rate? 1.9, so that needs to go here. Up here at R, it needs to become 0.019 to the t power. And there's your equation set up. Right? Now, let's go ahead and make this simpler so we don't have so many steps so we can get this video in here. Look, we need to make the amount that we're wanting to reach 8600. How long would it take? So again, you're solving for t, and we want that to become your 8600 on this side. So we're going to put that in. 8600. Right? And now we're going to take this equation, divide both sides by 7600, and we're going to see what we get. Okay? So let's come down here and redo this equation. I might as well type it, copy and paste it. Although that's not working great for me in these videos, I know that. But you guys, to be honest with you, I don't have time to do these over and over again sometimes. They just have to work. Just like if we're doing it in the classroom and something doesn't work, we just have to make do with it and keep moving on sometimes. Okay, so what I want to do is divide both sides by 7600. So I'll tell you what I'm going to do. I'm going to take the 8600. I'm going to divide it by 7600. And hopefully it'll give me a decimal. That's not too, it's not too great, is it? So we'll call this 1.1312. So that's what we'll call it, just for the sake of not having to use that fraction formatter over and over again. So we'll call this 1.1312. Is that what we have? Actually, it wasn't. Equals e raised to the 0.019t. Okay. All right, so this one's going to be a little bit easier than the others, actually, because you're going to take the natural log of both sides. And the reason you want to do that, because natural log base e, you're taking a, it is base e, and that's going to drop this down immediately for us. So your next line reads this. The natural log, make it an equation. The natural log of 1.132 is equal to 0.019t. That's nice, huh? So now the last step is to divide the natural log by 0.019. And that will give us our answer. So we're going to take the natural log So we want the natural log of that stuff, all right? And we're going to divide it by 0.019. And that gives us about 6.5 years. Notice how I copied that and put it back in. So we didn't really lose much accuracy. And I know I got a little bit sloppy on some of the work, and I will straighten this out for the notes. But anyway, that's how you would solve this problem. And does it make sense that it would take about 6.5 years? That's not an unreasonable answer. To the nearest year, so we call it, well, I guess we could call that 7 years. All right. Okay, thanks for watching, and the next ones won't be quite as long. I'm not going to try to slide 2 problems into them. All right, thanks, guys.